Alright, so in this video we're going to redo a problem that we've already done. It was a problem we did in the previous example where we solved the equation working with the fractions and eventually got our answer here, 19 over 12. Okay, we're now going to approach this problem a different way, and we're going to approach it by making the fractions disappear. Now, unfortunately, we can't just go in and erase the denominators. That'd be nice, but usually that's not going to give you a right answer. So instead, we're going to find the common denominator. So as we look at the three denominators, 5, 3, and 15, we ask the question, what's the common denominator for those fractions? What's the common denominator for those fractions? And in the case of 5 and 3, they both go into 15. So the common denominator is 15. Now what we're going to do is multiply the equation by 15. So that means everything is going to get multiplied by 15. So I go to this first term here. I go to this first term here, 4 over x over 5, and I'm going to multiply that by 15. Okay. I'm then going to continue and multiply my next term here, 2/3 by 15. And as I'm writing that, since those are fractions, I'm writing that as 15 over 1. And then finally, the last term here, 3/5, I'm multiplying that by 15 as well. So everything gets multiplied by 15. Now how does that help us? How does that help us out here? How does multiplying by 15 help us out? Well, notice what now happens here. I can go through here on the first fraction, and the 5 in the bottom can cancel with the 15 in the top. 5 becomes 1, 15 becomes 3. There's no longer a fraction in this problem, or in this part of the problem. We go to the second fraction there. I can cancel the 3 in the bottom with the 15 in the top, and that'll leave me with 5. So the fraction's been eliminated from that part of the problem. And then we go to the last part over there. The 5 in the bottom will cancel with the 15 in the top to be a 3. And at this point now, we have eliminated the fractions. They're no longer there because now we have 3 times 4 is 12x. Minus 5 times 2 is minus 10. Equals 3 times 3, which is 9. And now we have an equation that we can solve that has the same basic structure of the original equation, except it doesn't have any fractions. And so that makes the problem a whole lot easier to solve. So here we can go through and say, well, let's add 10 to both sides, right, to get the x by itself. That gives me 12x equals 19. And then we divide both sides by 12. And then we can simplify that fraction if need be. In this particular case, that doesn't happen. So we just get the answer x equals 19 over 12. X equals 19 over 12. And so now we have accomplished our goal. We have solved the equation by getting the rid of the fractions first, and then solved by getting the variable by itself. And this is usually going to always be a lot more beneficial. Now, if you're dealing with an equation like this first example that we had here, it's probably just as well to deal with the fraction rather than go through the extra work of getting rid of your denominators. But if it's any more complexity than that, then we are much better off, doing what we did here. Get rid of the fractions first. It's going to make things much easier.